Okay, this video is on graphing quadratics. There are three forms of the quadratic equation that we will be graphing. The top one here is the vertex form. The middle one is standard, and the third one is intercept. We have three different methods and ways that we can graph a quadratic. It depends on what form that you see it in. But we will start with the parent graph, which is just graphing the x squared function before we start moving it left or right, up or down, or stretching or shrinking it. All right, x squared. When we plug in -2 to x squared, we get a positive 4. When we plug in -1, we get a 1. 0 squared is just 0. 1 squared is just 1. 2 squared is 4. When we go to our graph to graph these, we're at -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And then we will connect, and we see that we have this U-shaped, we call it a quadratic formula. It's also a parabola. But if you notice here, this is our parent graph with our vertex being at 0, 0, and our A value being 1, H and K here is 0, 0. So we have yet to move this graph left or right, up or down. But we call this also the parent table. Okay, so these are points we will refer back to when I say parent table for the quadratic. If you look, we will focus primarily on these 3 points because 0, 0 is your vertex, 1, 1 is symmetrical with the point -1, 1. So we can use symmetry here. So if you can plot 0, 0, 1, 1, and 2, 4, you can have your corresponding points for -1 and -2. So these are the 3 forms that we will be working with this year. This video we will focus on vertex and intercept. The first form we're going to look at is vertex. We are now going to take our parent graph and we are going to see what happens when we shift it left or right, up or down, or what happens when we change the A value. All right, so our first equation, we have f of x equals 1/2, parentheses, quantity x minus 2 squared minus 2. When I look at this equation, I want to pull out my vertex first. Okay, so when I look at this, I see that my vertex here is 2, -2. My A value is 1/2. So remember the parent table we talked about. The parent table 0, 1, and 2. Okay, this is just thinking of when we have x squared, 0 would stay 0, 1 is 1, and 2 squared is 4. We're going to add a third column here because we have an A value of 1/2. So we are going to take our y values and multiply them by 1/2. 0 stays 0. 1 times 1/2 is 1/2. 4 times 1/2 is 2. Okay, so just to go back, we found the vertex. We go back to our parent table. Okay, we have to factor in this A is going to make our graph wider. So our y values are changing. We multiplied only our y values. So then our first step would be to plot the vertex. So we're 2, -2. Notice that we did shift to the right 2 and we went down 2. That has not changed from absolute value. We are now going to use our vertex as our reference point. We are going to plot the next 2 points off of our vertex, using our vertex almost like we would use the origin 0, 0. So from our vertex, if I'm going to plot the first point, 1, 1/2, I would go over 1, up 1/2. Okay, now I went over 1, up 1/2. I also use a point of symmetry there, can go over -1 and up 1/2. Notice I'm using the vertex as my starting point. Okay, the next point, 2, 2. So from the vertex, I'm going to go over a +2 and go up 2. Okay, go over a -2 and go up 2. And we have plotted our quadratic. It is U-shaped. So notice the thing that was different here is that we found our vertex and we used our vertex as our starting point to plot our other 2 points. And then we used symmetry to get the points on the other side. So some questions: with this graph open up or down? Since the A value is positive, the graph is going to open up. Does this graph have a max or a min? This graph has a min because it has a low point right here. Okay, so we call that a min. And when we ask for a max or a min, we want to know how low, what is the y value at that point. So we have a min at -2. Does this graph have a vertical stretch or shrink? Since our A value is 1/2, okay, we have a shrink. The vertex of this graph was 2, -2. All quadratics have an axis of symmetry. You get that. They have to be written as an equation. Okay, the axis of symmetry here is that vertical line that goes through the vertex. And we write them as an equation that would be x equals 2. It does have to be written as an equation. The roots of this graph, if you remember, roots are solutions or x-intercepts. So you're looking to see where that graph crosses the x-axis. So the roots here would be 0 and 4. The x-intercepts have to be written as an ordered pair, would be 0, 0, and 4, 0. The domain of this quadratic is all reals. The range, we have to read from the bottom to the top. So you look, the first y value we hit is -2, and it's included, and then it goes on up to positive infinity. So you could write that as y is greater than or equal to -2. That is set notation. Interval notation would be hard bracket -2 to positive infinity. The next 2 questions are in behavior questions. That is where we were looking at what is happening to the end part of our graph, which way are the arrows going. So for the first one, as x is heading to the right, what is happening to my y values? Well, they were going to positive infinity. As x is heading to the left, what is happening to my y values? Well, they are also going up to positive infinity. Increasing and decreasing intervals, we are thinking for what x values are my y values going up? So if you look at your graph, we are increasing, and you're also thinking kind of positive slope, we are increasing from x values 2 to positive infinity. Decreasing, as my x values are getting bigger, my y values are going down. So we are decreasing from negative infinity to 2. Once again, when I'm doing increasing and decreasing intervals, I am looking for the x values. The last question here, if f of x equals 0, then x equals. This is another way to ask for what are the solutions. the roots, the zeros. Okay, it wants to know when is y going to be 0, and that would be 0 and 4. Okay, the next one, notice here we have a negative a. So if you remember back to absolute value, a negative a is going to flip our graph upside down. Our a value here is -1. My h and k, be careful there, it's x plus 1. So we know we're pulling out a -1, and my k is a -3. Let's refer back to our parent table. Always using the same x values. It's 0, 1, and 4. I have to reference what my a is. My a is -1, so I'm going to multiply everything by -1. And then my first step is to plot my vertex. So I'm at -1, -3. Remember what I said about the vertex. We are going to use that point now to plot the other points. Okay, we're going to use this almost like it would be our starting point or our origin. So now we would go over 1, down 1. Okay, I will do my point of symmetry on the other side. If I go over -1, I'm going to go down 1. Okay, the next point, I would go over a +2, but down 4. So I go over 1, 2, down 1, 2, 3, 4. That point on the other side, if I would go a -2, I could go down 1, 2, 3, 4. Okay, check to make sure that your graph is opening down. Make sure that you have shifted to the left 1 and down 3. Okay, this graph opens down because the a value is negative. Because this graph opens down, notice we have a max point, and we're looking for the y value. So we have a max at -3. This particular graph does not have a vertical shrink or stretch because the a value is still 1. Its vertex is -1, -3. Remember, axis of symmetry is that vertical line that comes through that vertex, and it has to be written as an equation. So that would be x equals -1. If you look at this graph for the last question, and I'm asking for the solutions, you do not see the graph cross the x-axis, so there will be no real solutions. Okay, the third one, my a value is 2. My vertex, be careful here, it's -3, -8. I'm going to go to my parent table. 0, 1, 2. 0 squared is 0. 1 squared is 1. 2 squared is 4. I'm going to create my third column because my a value here is 2. So I'm going to multiply my y values by 2. Then my next step is to plot my vertex at -3, -8. And I just do a little mark there, so I now know that I'm going to use that vertex to plot my other points. So 1, 2, I'm going to go over a +1, up 2. I can also go over -1 and go up 2. I could go over a +2, and then I need to go up 8. So go over 1, 2, go up 1, 2, 3, 4, 5, 6, 7, 8. I can go over a -2 and go up 8 also. Okay, this graph opens up because my A value is positive. Since it opens up, I have a minimum, a low point there. That's what we call our min. And we're going to look at the Y value there. So I have a min at negative 8. Since my A value is 2, I do have a vertical stretch. And my vertex here was negative 3, negative 8. Remember, once again, I have that axis of symmetry, which is a vertical line coming through that vertex at x value, at x equals negative 3. Zeros, solutions. If you look at this particular graph, it does cross the x-axis. So the points I'm concerned with would be, where does it cross? Well, it crosses at negative 1 and negative 5. Now that we looked at graphing a quadratic in vertex form, let's look at some graphs and see if we can actually write the equation. The equation is at the top of your screen here. So if you look at this, the only things we need are the A value and the vertex. Once we have those things, we may plug it into the equation. So looking at our graph here, our vertex is 3, negative 4. So I'm going to go ahead and plug that into my equation, leaving space for the A. I have x minus 3. Don't forget the squared. That's what makes it a quadratic. X minus 3, quantity squared, minus 4. So you pretty much have the equation written, but now we need the A. Once again, I'm going to reference that parent table. So we have 0, 1, and 2. 0 squared is 0, 1 squared is 1, 2 squared is 4. Okay, so this is new. Let's look at our graph here. And we try to find some good points. If you were to graph a quadratic where the A value is 1, you would go over 2, up 4. Watch. I would go over 2, up 1, 2, 3, 4. That clearly does not happen here. Instead, I go over 2, but I'm only going up 1. So I go over 2, but instead of going up 4, I go over 1. So how do we get, this is where our A value comes from. So we know this is what we want A to be, so we're going to solve this equation. So to solve this equation, remember we did 4 times A to get this 1. So this is a little equation we can solve. 4A equals 1, divide by 4, A is 1/4. So I will fill in my equation, and there is my A, 1/4. And that is the equation of this quadratic in vertex form. Later we will come back and look at intercept form and standard form. Let's try another one. So if you remember, the equation for vertex form is f of x equals A, x minus h, don't forget the squared, plus k. So looking at your graph, we need to get our vertex, which is 3, positive 4. I'm sorry, it is 4, 3. We went over 4, up 3. So we can go ahead and plug that into the equation, leaving a little space for A. So it's going to be x minus 3. I did it again, I apologize. X minus 4 plus 3. And I'm not going to forget my squared right there. Now, let's go back to my parent table. 0, 1, 2, 0, 1, 4. And remember, we're looking for this a, so I knew that I multiplied my y value by this a. Let's see which one gives us a good point that we can use. If I normally would go over 1, I would go up 1. Well, that's not the case here. I went over 1 and went down 1, 2, 3. So we're going to say that's negative 3. So you can solve your equation. It's a very simple one. 1a equals negative 3, or a is simply just negative 3. And I'm going to fill in my a. And I have the equation written in vertex form. Let's look at one more of these. Remember, again, we are trying to figure out our h and k and our a. So if we look at our graph here, our vertex is negative 5, negative 1. We can go ahead and plug that in, leaving space for our a. Now, I'm plugging in a negative 5, but there's already a negative there, so that is why this is going to become x plus 5 squared minus 1. Now let's go back to our parent table. We have a 0, 1, 2, 0, 1, 4. Remember, we are multiplying these by a to get what the actual point is. So let's look at our graph. Normally I would go over 1, up 1. That's not working for us. Even if I go over 1 and go, that's just not a good point. So I'm now going to try the 2. Normally if I go over 2, I'm supposed to go up 4, but I did not. I went down a negative 2. So here's my equation I need to solve. 4 times a gave me a negative 2. So if I divide by 4, a is negative 2/4, or I'm going to reduce that to be negative 1/2. Fill in your a into your equation. Double check, make sure you have your squared up there in the sky, because that is what makes it a quadratic. The next form we are going to do is intercept form. It looks different than vertex form. Vertex form and intercept form both have an a, but notice in vertex form we have an x minus h quantity squared plus k. An equation written in intercept form is also already what we would call in a factored form, which means we can pull out the zeros. So if we look at number 1 here, very quickly I would notice that this is in intercept form because we have two binomials that we're multiplying together. So I pick up that my a value is 2, and I would know, if you go back to your Algebra 1 days, that if we were to solve using the zero product property, these equations for 0, we would get x to be negative 3 and x to be 1. Okay, those would be our solutions and would be x-intercepts for us. How do we get the vertex of something that is in intercept form? We take our zeros and we average them together. So for this graph, to get the vertex, I would take negative 3 plus 1, and I would divide it by 2. That gives me negative 2 over 2, which is negative 1. That gives me part of my vertex. I now know that the x value is negative 1. How do I get the y value? Well, I'm going to plug it into my equation. So I would have 2 times negative 1 plus 3. negative 1 minus 1. So this would be 2 times 2 times negative 2, which is negative 8. So my vertex here is negative 1, negative 8. So when you graph in intercept form, you still plot the vertex first. So we're at negative 1, down 1, 2, 3, 4, 5, 6, 7, 8. You do have two other points you can graph because they are solutions. So we are at 1, 0 and negative 3, 0. Now, I will refer back to the parent graph again because we have an A value of 2. So we have 0, 1, 2, 0, 1, 4. I'm multiplying everything by 2. That's going to give me a 2 and an 8. So that helps me get some accurate points for my graph instead of just using freehand. So I would go over 1, up 2. I could go over a negative 1, up 2. Now watch, when I go over 2, up 8, I am clearly at where my zeros are. Looking at our graph, let's answer some questions. A value is positive, so we open up. Since we open up, we have a minimum, okay? And the minimum here is at negative 8. That's our Y value for our vertex. Since our A value is 2, we have a stretch. Our vertex is negative 1, negative 8. Still have an axis of symmetry, all quadratics will. It is that vertical line that goes through that vertex. So it's at x equals negative 1. Roots are solutions, are intercepts. So we know that our roots are negative 3, 1. The intercepts are our roots written as ordered pairs. The domain for this quadratic is all reals. The range we read from the bottom to the top. So y would have to be greater than or equal to negative 8. That's set notation. You could write it in interval. That's hard bracket, negative 8 to positive infinity. The next two questions deal with the end behavior. So we're looking at what way are those arrows pointing as x is going to the right. Our y values, our end behavior, the arrow is pointing up. As x is going increasingly negative to the left, our end behavior is going up. Increasing and decreasing, once again, we are talking about x values. So we want to know for increasing, as x is getting bigger, our y values are getting bigger. And for what x values is that happening? That would be negative 1 to infinity. Decreasing would be for our x values are getting bigger, that our y values are getting smaller. And that would be negative infinity to negative 1. The last question down here is another way for us to ask you for the solutions, the roots, the intercepts. When y is 0, what values of x will make y 0? Well, we already solved for those in the very beginning. That would be negative 3 and 1. Let's try another one. This is an intercept form. It is a factored form. So since it's an intercept form, we start the vertex by first we need to find the solutions or the zeros or the intercepts. So here we have x equals 0 and x equals 4. We're going to take the average of them or simply add them up and divide by 2. That'll give me 2. That only gives me the x coordinate for the vertex. So I will need to take this 2 and plug into the equation. So it's 2 parentheses 2 minus 4. That's going to give me 2 times negative 2, which is negative 4. So I now have my vertex. I have 3 points that I can plot. I have 2, -4, 1, 2, 3, 4. I have a 0 at 0, 0, and I have another one at 4, 0. I'm going to refer back to the parent table just so we can make sure we have accurate points. 0, 1, 2, 0, 1, 4. What's my A value? Well, A is 1 here. So I don't need to multiply these by anything. So just to double check with our graph, I'm going to go using my vertex. I'm going to go over 1, up 1, use my point of symmetry, go over 2, up 4, and we're right where we need to be. So this graph opens up because my A value is positive. It is a min at -4. Remember, I'm looking for the Y value. There is no vertical stretch or shrink because the A is 1. The vertex is 2, -4. Remember, that axis of symmetry is right through the vertex. It's going to be that equation, x equals 2. And my solutions would be 0 and 4. Let's look at one more. This is an equation of a quadratic. It's in factored form, so it's intercept. I do want to be careful because it actually is an inequality. So remember, with an inequality, we have 2 extra questions to ask ourselves. Dotted or solid line, and then we have to think about shading. All right, so the first step, let's get our zeros. X minus 3 equals 0. X plus 2 equals 0. X is going to be 3 or -2. So to get the vertex, I'm going to take the average of these, and I get 1/2. That's only the x coordinate for the vertex. So I will need to plug 1/2 into the equation. So I get 1/2 minus 3 and 1/2 plus 2. That is going to give me -5/2 times 5/2, which is -25/4. If you convert that to a fraction, that's -6.25. So the points we do have, now we're going to have to be careful here because it's 1/2 down 1, 2, 3, 4, 5, 6. 0.25, you're just going to have to eyeball it a little bit there. Do the best that you can do. And then we're going to plot our zeros. So we're at -2 and 0, 3, 0. Let's refer back to that parent table again. 0, 1, 2, 0, 1, 4. Check your A value. If it's 1, we are okay. I don't need to multiply by anything, but it will help me get these other points. So we're at 1/2 here, so I'm going to go over 1 and go up 1. And I'm going to do the same thing. I'm going to go over -1 and up 1. And if I go over 2, okay, and I'm going to go up 4. So that is going to give us some extra points to make sure that our graph is accurate. I know it's a little bit harder when it's a fraction. Our A value was positive, so we open up. So that gives us a min value at -6.25. A was 1, so there is no vertical stretch or shrink. We got our vertex to be 1/2 and -6.25. Even though this is an inequality, which I'm going to reference back to here in a second when I ask about dotted or solid or shading, you still have an axis of symmetry, and it's going to be x equals 1/2. So let's go back and look. We have a greater than. Does not have an equal to sign. So instead of a solid line, we are going to make that a dotted line. We also have to ask ourselves, it's a greater than So we're going to shade up the y-axis. So then when it asks for a point in the solution set, it could be any point in the shaded area. Do not use a point that is on the dotted line, because that means it's not part of the solution set. I'm going to pick a nice easy one right there, 0, 0. The last part of this is we are going to go back and now look at these graphs of quadratics and see if we can put them in intercept form. Part of our battle is done because we already figured out what the A value was when we did vertex form. Intercept form, we need the zeros. So here I see that my zeros are -1 and they are +7. We need to remember when we go from zeros to factors that if your 0 is -1, your factor is x plus 1. Let's look at this. If your 0 is 7, then your factor is x minus 7. So when I want to write something in intercept form, put your a value first, which is 1/4, and write your two factors, x plus 1, x minus 7. And you are done. If you want to recap a little bit on how we got the a value, we reference the parent table, which is 0, 1, and 2, 0, 1, and 4. We knew we got a by multiplying the y value by a. So I looked at my graph, I went over 2, but instead of going up 4, I only went up 1. And I solved this equation. Let's look at the second one. I look at my zeros here at 3 and 5. So remember, if x equals 3 is the solution, the factor is x minus 3. If x equals 5 is the solution, the factor is x minus 5. We already had the a value from vertex form. So intercept form would be f of x equals, use your a value, -3, x minus 3, x minus 5. Last one. We know that the a value is -1/2. We got that when we did vertex form. We cannot write this one in intercept form because if you look, we don't have any intercepts. So there would be no intercept form for this equation. That happens when we do not cross the x-axis. But let's look forward. How would we write this in standard form? If you remember back from your Algebra 1 days, standard form of a quadratic is ax squared plus bx plus c. If you already have a form in vertex form, you can convert it to standard by just doing some algebra. So we are going to take our vertex form, and I'm going to convert it to standard. My first step is to expand that out. And you have to FOIL or multiply x plus 5 times x plus 5. You notice that is not x squared plus 25. We are going to have a middle term. Do your multiplying first. So we get -1/2 x squared. And then we're going to have 5x plus 5x, that's 10x. And then we do our last terms, we get plus 25. Notice I close those parentheses, leave the -1 there. The next step you have to do is distribute the -1/2. The -1/2 only goes to the x squared plus 10x plus 25. So I would have negative 1/2 x squared, negative 1/2 times a positive 10x is a negative 5x. And then you have a negative 1/2 times 25. That gives us a negative 25 halves. Make sure when you distribute the negative through that the x squared is negative, negative and a positive is a negative, negative and a positive is a negative. We still have this minus 1 here, so we're almost done. We're going to have negative 1/2 x squared minus 5x. And then you have negative 25 halves minus 1. Get a common denominator, so it'd be 2 over 2. So we would end up with negative 27 halves. Now we're writing an equation, so I'm going to set this equal to f of x or y. So in order to go to standard form, we took vertex form, we FOILed distribute, and then combined like terms. And we have our equation in standard form, which once again was f of x equals ax squared plus bx plus c.